All right, welcome back to another week of Kernel Dev Gardening. Week 23, I think. And this week we're working on Userspace, finally. We're definitely not going to get through this whole thing today. We even started it a little bit last week, but we're going to keep going with this MIT lab, lab 3. And I think, yeah, there was a bunch of kind of detailed stuff that I didn't fully read through, but I just started with lab 1. I'll also quickly make sure my chat is working, test 1, and just see if the chat plugin is working today. Right. So we're pretty much kicking right off where we left last time. And last time, we were allocating memory for all of the environments, which are kind of like runnable contexts or something like this. Or actually, no, I mean, no, they're like processes basically. And for some reason, the JOS operating system, which I'm working with right now, doesn't use the term processes, but that's what they are. And so there are some, I believe it's a fixed number of environments or processes that are runnable at a time. I should probably take the time to understand this better. Yeah. Environment and process are interchangeable, but there are some technicalities about why they call them different. So processes, a bunch of new kind of skeleton code available to us. Right, so kernel uses the end data structure for each environment. We're just doing one environment right now, but we will need to support multiple environments later. Okay. And there's some global state. Okay, we've all the environments, the current one, and some kind of free list. Right, and just kind of a key point of info is that it's a compile time constant, I believe, or yeah, effectively it's a compile time constant of the maximum number of simultaneous environments at one point. And just to remember what actually is that constant. 1, 2, or 2 to the 10, which is what, like 512? No, 1024. We did this last time. Right, okay. Okay, so and then there's a currently executing environment at any given time. You set to null. These are the actual details about what an environment or process looks like. There's all these fields, and this is what I did. So now we need to actually allocate this array of n env environments, and I did this last time. I'm just gonna move this over here so I can see it more easily. So allocate and map the ends array. End instances of the end structure. Also the pages array should be mapped user read only for some reason at some certain place. And so it was these two things. So first thing, allocate the actual space for the environments. It's env is the number of them and size of an environment. And then clear that to 0 because that won't be done for us by bootmalloc. And then part 2 is controlling this mappings thing, in which case we do a very similar pattern to the above. We're trying to expose this data to Userspace for some reason, which I guess will be revealed to us later. And to do that, we use bootmap region. We pass the page directory. You pass the destination virtual address, which this should all appear at. We pass the range and a starting physical address and a permission. And in this case, it's UPT, just like above. Okay. You will now write the code in kernel.env.c to run a user environment. Because we do not have a file system, we will set up the kernel to load a static binary image that is embedded within the kernel itself. And that's going to be the first process, basically. But yeah, so like there's no way to access a file system or any kind of storage. All we can really do at this point is bake in a program into the kernel. And I'm just thinking about, like, as opposed to normal operating systems, like what does a Linux do, for example? When it boots up, you pass it a root file system. You pass it some kind of like argument, typically of like a root file system to use, or maybe it's a partition, I kind of forget. And then when the kernel is finally done initializing itself, it goes and executes the init process at some kind of hard-coded path into the file system, like /sbin/init or something like this, which is what this is talking about. And so because the Linux can work with file systems, it can then retrieve the next part of the boot process from the file system, but we don't have this yet, so we need to bake this in to the kernel. Okay. I'm going to do a test 2 in the chat because I didn't see the test 1 appear in the chat widget, so I'm kind of concerned that it might be broken or something again this time, which would suck. But sometimes there's a bit of delay. Okay, test 2. So yeah, I think there's sometimes a bit of delay, and Streamlabs isn't quite ready to receive the things until like a minute or 2 after the stream starts. Okay. The makefile generates a number of binary images an object user. If you look at kernel makefile, you know some magic that links these binaries directly into the kernel as if they were .o files. The B binary option on the linker command line causes these files to be linked in as raw, uninterpreted binary regular rather than regular .o files. Hey, entertainment.exe. Welcome. Bauer. Okay. And fun fact, this pattern is used in XV6 also. It's interesting, yeah. So like for the first, I think 13 episodes of me doing my weekly streams, I was using XV6 rather than JOS, and XV6 uses exactly this pattern. And at least one way, but this is how it bootstraps Userspace. It like, it's a little bit detailed to get into, but it like creates this kind of basically extremely minimal assembly program that just triggers an exec system call of an init process, of like an init system call, an exec system call of the init program, but it uses the same technique. That always seemed kind of messy to me, but whatever. Yeah. Hey, Roshan. Okay, nice. So anyway, so we have all these things. So I wonder if I could even see them just for fun. Thanks, man. Appreciate the motivation. Yeah, trying to keep going every single week. Okay, so I can see what they're talking about already. We have these various user blobs or whatever. Kernel make frag. So we have the kernel source files, and then we have some binary program files to embed within the kernel. And that's our substitute for having a file system. That's funny. That's my guess. My guess is that these are all just kind of binaries that will run within the OS. And I am wondering how they are built, actually. I also am even wondering what they look like. Like, what does hello look like? So it's a program that has some kind of main function, and it can call some stuff, breakpoint. Right, so these are our basic Userspace programs, and just curious, yeah, how are they built? I kind of am overwhelmed by looking at this makefile stuff. Wow, it's kind of, so it takes CC user. I mean, this is okay. A couple of things here. So step one is that it builds the C programs into .o files. And it has some user C flags or something. But critically, it's passing -c, so it only builds the object file and doesn't try to link it. And then what do we have here? I actually kind of don't get this. All right, 20-second break. Be right back. Okay. Kind of don't. I want, oh shit, did not mean to do that. Execute. So I want to actually just look at the breakpoint sim. Okay, so the symbols, breakpoint.asm. This should be a very short function. umain. So this is the umain is that's the actual application, and then the rest of it is just the C runtime, which is also kind of rolled from scratch. And all these like library functions apparently. Interesting. Okay. I think I get the point. And I think just one other thing I would want to do is take a look at what the readelf looks like for this. Okay, I mean, it's an executable file. So it's not just a unlinked.o file, I guess, of course. Okay. I'm just curious, yeah, can we take a look at this? So if you look at the symbols, you'll notice that the linker has magically produced a number of funny symbols. Right, so these are the funny symbols. I think none of them are actually used. Okay, except for a little bit. Yeah, hey, digitalized, yep, moving on to lab 3, which is actually kind of exciting. It's Userspace. Okay, so now, okay, time for exercise 2. This looks like a big exercise. Okay, let's see code to run one of these binary images in an environment. However, the critical functions to set up the environments are not complete. You need to do them. Okay, let's do them. Let's do it. Okay, and just going to, I don't know, clear some of this stuff out until it's needed. Right, so file env.c finish the following functions. Env init, initialize all of the env structures in the array and add them to end free list. Share the link, yeah, you got it. Not quite sure how to pronounce your name, Mustakwa, maybe? But yeah, here's the link. And I would very much welcome anyone that wants to work on these with me, or work on these in parallel. Yeah, initialize all of the env structures and add them to the free list. Also calls env init per CPU, which configures the segmentation hardware with separate segments. Interesting. Separate segments for privilege level 0. Interesting. Okay, those details are not quite so fresh for me, but let's go to env init. I'm actually going to move. Yeah. Okay. Mark all environments as free. Set their env IDs to 0 and insert them into the. Set their env IDs to 0. Okay. Yeah. And insert them into the env free list. Make sure the environments are in the list in the same order they are in the envs array. So the first call to envalg returns. Okay, so I always find it helpful to sketch this stuff out, and luckily we have basically like an exact thing that we need here, basically. So it's the exact same structure as the free list, ends free list. And this starts out pointing to null. Oh wow, what's up? I want the curvy line, and I want it a bit bigger. No, I don't want text. I just kind of want that line to be a bit, okay, there we go. Right. So we have our array of all the m's, and we're trying to okay, time to look at it. So what's in env? Each env, like so far I've zeroed all this stuff out. Env ID, Userspace, okay. Make sure the environments are in the free list in the same order as in the array. So the first call returns m's 0. Okay, so what's it gonna look like? So we have this, our m's pointer, and the goal is pretty much each one points. Okay, now these lines are a bit too thick. Each one points to the next, each one points to the next, and then this one points to null. Right? I think the first, because env alloc probably is just going to it's just going to probably just take, like, it's going to pop something off of this like list, basically, starting from that. So, okay. Okay, so now we just need to initialize this. And how are we going to do that? I think the way we did it last time was kind of like working backwards or something like that. So we're going to need some kind of loop, obviously, through all of them. Just out of curiosity, what would it look like to loop from, just do the simplest version of loop from the start to the end? So maybe this is, I see. Okay, so it's I equals 0, I is less than n. That our basic loop construct. Oh, okay. But it's kind of, yeah, like if we were to do just some kind of loop, it's kind of tricky because we want n's free list to point to the first one. I have some kind of suspicion that we want to actually iterate from the end to the front to construct this thing. Yeah, so if okay, I'm just going to make a kind of guess here. Struct env. I have a pointer to env, and previous I'm going to call it null, and some kind of thing where it's like as I, what was it? Env link, which is the next. It's going to be something like this. And then prev equals something like this. Yeah, I'm just kind of coding a little bit intuitively. I don't really know if this is right. That's curious, is that right? Why is it squiggly then? Oh, okay, I see. It's not. Thanks for the warning. Okay. Now what's wrong with this? No, that's right. Okay. So basically, I actually want to iterate from the end. So starting at I equals n minus 1, and then decrement it every time while it's greater than equal to 0. And then when it goes below 0, I want to stop. And fun fact, that's also a benefit of using a signed integer for the counter here. Okay. Because if you use an unsigned integer, which some people like to do for counters, it actually gets kind of trickier here to do the condition and stuff. So my general intuitive sense of the algorithm is like we could have this previous thing, and then let's imagine we only had one, like a single env in this list. So we're going to set the env link to null, and then env free list equals like the pointer to the current one, basically, which we kind of already have. I'm pretty much always a big fan of unsigned ints for looping. Yeah, I don't know. I've gone both ways on this, but lately I'm kind of just a fan of simple signed ints, actually. You know, yeah. Okay, but so I think that's kind of right. So if we only had one. I mean, whatever. I think this is simple enough where we can just, I think I kind of did it. So this thing starts out at null. So prev is this value that points at null. And then what happens? And so we start at the last one, and we say next is equal to prev, which is equal to null, and free list points here. And then prev also is moved to point here. And then on the next iteration, we then go to this one, and we're saying, okay, so this one links, to here, and free list now points to the current one. So I'm just going to say struct and current equals ends. What's the easiest Vim way to do that? Current, right? Move this up higher. And I'll even just say current. Yeah. So current. And I think I might even be able to optimize this. Like it kind of seems like the prev and end free list are redundant even. Actually, so end free list. I'm just going to set. I think it's already set to null, but just let's see if this works. So we're getting rid of this prev thing, and free list points to null off the bat. Let's get rid of all these arrows. Step 1, get the current one, and then step 1, point its env link at ends free list. and then now end free list points here. Next iteration, go to the next one. Current end free list, or yeah, next points to the current value of end free list, and end free list goes to current, and that produces this structure. And I am pretty confident that this works, although who knows. Okay, and then what do I need to do? So I'm pretty sure I did that, and then set their env ID is 20. Current env ID equals 0. Yeah. Okay, nice. So we're using the end free list variable as kind of like a previous yeah, as like the previous one. And then every time we go to a new one, we use it. We're basically just kind of inserting at the front of this list, basically. Okay. I'm going to need to commit this, I guess. Okay. Yo, too fat to kidnap. What's up, man? Welcome back. How are you doing? Yeah, I hope everyone is having a nice time on this chill Sunday. At least it's pretty chill for me. All right. All right. As you write the function, you might find the new sequence of a verb %e useful. I don't know what that is. It prints a description corresponding to an error code. Wow, that's pretty cool. Where are they using? Okay. Just curious. I wonder if they have these nice, like, check functions, which I was using last time. Let's see, because those are very helpful as basically unit tests to see that I got things right. I'm not totally sure they have them though, so I might be on my own. Check. I don't really, I don't see anything, so, I might need to write my own unit tests, which I kind of don't want to waste time doing, but that's what everyone says about unit tests. All right, 20 seconds, be right back. Yeah, like just for fun, where would I even write the unit test? So I'm trying to find the start of this again. Where's mem init called? Here. Okay, then okay, so just for context of what the call stack is, we're in IA386 init, and we did all this memory initialization stuff last time. Now we're getting into what I just did, it's calling env init. So I might just add some. I might just add like a unit test function, check env init, and void check env init. I'm kind of, like, I kind of don't know how to do this, but yeah. So let me just take some inspiration from these other checker functions, like this one. Just in terms of how they work. So they basically just use assertions. So as like a first point, I'm just gonna do like assert false. And let's just see that things fail. Okay, so it failed at this pmap 227 thing. I also didn't save that. Oops. 227. All right, so I think I can remove this line and continue execution to my next panic, which is going to be here. So I don't want this panic at all anymore, and rather I want to panic around the point where I haven't implemented things. I'm just going to call this I'm going to say unimplemented. Okay. Or I'm just going to say like, I want to say something like edge of the kernel. Like have only implemented this far. Okay, yeah. And now what? I'm trying to just see this thing. Implicit declaration of function, because I probably didn't add it to a header. Just curious. Yeah. Okay. Assertion failed, false, good. So now I have a little place I can do some tests if I want to. For example, I can assert that free list equals envs 0, because that was one condition that should have been satisfied. And also, just like on a quick side note, I guess I could also technically do these assertions at the end of this function. But no, I mean, this is like the production code. I kind of don't want to, like, as much as possible, I don't want to clutter the production code with like this testing stuff. So for example, this was like a super basic condition that we wanted to like preserve or implement. And I think I did it right. Like the test just passed, so I think I did it right. But for example, I can then inject a bug like all good programmers do, because I'm a good programmer or whatever, or I'm trying to be. And for example, I inject a bug that's like, what if I were to get this condition wrong? And that means I'm actually running one too few, and I'm then the test should fail. And it fails, 138. Assertion failed, and free list is equals this thing. So that is actually kind of cool. I like that. So that's officially our first unit test. There were some other, some other things. Their env IDs should all be 0. So I can assert env ID equals 0, for example. And then I can like inject a bug where I set them to 42 instead, and that should fail. Then I can fix the bug and see that the test passes. So I'm just gonna say tests passed, just to help me understand the message a bit. Yeah, false and test passed. I believe that's kind of like some kind of C convention to like have like a message in your assertion or whatever, at least with standard asserts. So I'm now asserting that they're all 0. I kind of want to, I mean, maybe it's good to label these two. I don't know the best way to do this. And free list has elements in same order as allocated in memory. For example, all have env ID equals 0. That's a bit self-explanatory from the test. Has env elements in case I had a bug and didn't do that. So num envs equals 0. Assert envs equals menv. Pretty sure that passes. Test passed. What else? That was pretty much it. I think I could inject the bug again to say. Right. So if I inject this bug, where it goes all the way it starts from the end, but doesn't completely get all the way to the beginning, our earlier test will fail. It's going to be the one that says assertion failed and free list equals blah, 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 blah. But I can also inject a different bug where in order to do that, it doesn't start totally at the end. It starts a bit further into the middle than it should, and it still ends at the first one. So that means that test that just failed, this one, that's going to pass because it's going to basically it's going to make it here. So basically what I'm doing is I'm starting, like, rather than starting at the very absolute last one, I'm going to inject a bug where I'm starting kind of like a little bit too early, and therefore it's going to leave out this one, but it's still going to end on the first one. So that first test is going to pass, but this last one should now fail. Oh, did it not fail? Oh, but did I not have the, wait. Oh, wait, but I'm dumb. Wait, okay. It's very, very stupid. Of course, I didn't test anything. Yeah, that was so dumb. What I need to do is actually block the list. So I need I need a current, which I'm going to set to end free list, and while current ends, and also current equals current, what was it, next end link, something like that. Okay, now this actually walks the list. And so it's basically just doing, so I'm going to point it, okay, is this correct? So it points, so it starts out as a pointer, oops. So we're starting out pointing at the first one, current equals ends free list, and just gonna fill in these arrows real quick. We're gonna start here, and if it points to something, which it does, we increment the counter and then move on to the next one. That does something at the very end, move into the next one, increment ends, and then current points to null. And then current does not exist anymore, current does not pass. So I think that's correct. So now I hope this test fails. Assertion failed, num ends equals nenv. And then I'll fix it because by removing the bug that I injected. Test passed. Okay, nice. That feels good, just to have a bit of like unit tests for this little function, just to make sure I did that right. But it appears that I pretty much nailed it on the first try, so that's pretty cool. Okay. And apparently I'm touching a bunch of different stuff here. So what do I want? I want these two, I want this thing, and I'm gonna say add test for env init, and I'll do a little, I don't know. I'll just leave that. I'll just leave that in the working tree. Okay, so now it didn't tell us that we had to do that, but I just kind of felt like it was important to have a bit of testing. And it's a good habit to get into. Env setup VM, allocate a page directory for a new environment, initialize the kernel portion of the new environment's address space. Okay, I don't really understand that, but we'll get there. Env setup VM. Okay. So, bunch of details here. Okay. Initialize the kernel virtual memory layout for environment E. Allocate a page directory. Set the pointer accordingly, and initialize the kernel portion of the new environment's address space. Do not yet map anything into the user portion of the environment's virtual address space. Turn 0 on success, negative on error, including this one. Okay. Man, I always forget all the memory allocators. I'm gonna make a list somewhere to help me remember. So, because we need to allocate memory allocators, and we have what? We have the boot alloc, which is what? And that's the initial bump allocator. Then we have page alloc, works on arbitrary sizes. Kate's pages of physical memory only works on page size. Like, this is used to bootstrap page alloc. And that's pretty much it. Page alloc, yeah. Page remove. And there was that important thing where boot alloc is supposed to be like never used after page alloc has been initialized. And I always kind of confuse the two, but that's what we see here. There's page alloc being used. And so given an environment, it already kind of did the work for us, and allocated a page. Okay, that was the easy part apparently. So now we need to, I mean, that's this page dir, that's the easy part. That always points to P, I believe. Or no, wait a sec. Page and page dir is a PDET. And page alloc returns a struct page info. Oh, so that's like annoying. So that returns a physical page, and it's always so annoying to do this conversion. So you need to kadder? I always forget the macros. Kadder is the macro to take a physical address and return the kernel virtual address, which is what we want. And I think it returns a void pointer, which should be okay, because it then gets consumed here as a PDET. Okay, so we have a frame of memory. And now we need to initialize, I guess I'll just move this down. And initialize the page directory, which, okay. The VA space of all M's is identical above utop. Let's check out the memory layout reference, just for reference. Utop is here. The VA space of all M's is identical above utop. It's just all this like kernel stuff. Although UVPT, it said. Can you use current pager as a template? Hint, yes. Make sure you got the permissions right in lab 2. The initial VA below utop is empty. You do not need to make any more calls to page alloc. Okay, good. In general, ppref is not maintained for physical pages mapped only above utop. But env pagedir is an exception. You need to increment env pagedir's ref for env free to work correctly. Okay. So that means I need to increment the ref count, right? Which I think is pretty simple. Okay. You need to increment env pagers pp free for env free. So I believe that's what I did. The functions in kern / pmap.h are handy. All right, 20-second break. Be right back. Hey, Amen FX. I'm doing pretty well. How are you doing? Yeah, I'm having fun. Today's a good stream. I feel like I'm making pretty solid progress. The functions in kern pmap.h are handy. What are those again? Okay, it's this p-adder macro, the k-adder macro. Okay, these various helper utility. Oh wait. Okay. Okay. I'm just. Okay. I messed up. I can't call k-adder directly on the page info. I need to. You can only call it on the physical, like actual physical addresses, and a page info is not a physical address. So I actually need to call page2kva. Time to do some C++ reading with the stream in the background. Nice, good luck. Good luck. Let's see that. What part of C++ are you reading about? Okay. Can you use current pager as a template? Yes. I think I need to step back for 1 second and even understand this at a bit like a higher level context. So I have been working, like the last several streams, I was working on setting up the kernel virtual address space, which involved manipulating the kern pager, which is which is kind of like this global variable basically. Chapters on templates. Oh man, templates. That's like especially, it can be especially dry stuff. Nice, nice. Have fun with that. All right. Yeah, the current pager is like this global variable basically that that is just, it's just how the kernel accesses virtual memory, or like uses these page tables to define its virtual memory layout. So yeah, here, and so I did all this work to initialize it, which is going to be somewhere here, I think. Current pager. But was it all boot map region? Pretty much. It was entirely boot map region calls, basically, to initialize the current pager. Because we, except for that weird thing with the recursive insert PD in itself, man, I still don't get this line. It said you don't have to understand this line. Good, because I still don't get it. A virtual page table at virtual address UVPT. Also, that's so interesting that it directly sets the page directory entry with this assignment. But, So this inserts a mapping into the page tables where if you start accessing addresses around UVPT, those get resolved actually to the kernel's page directory. In read-only. What? It says permissions, kernel, oh wait, yeah, kernel and read and user readable. It's interesting that we allow Userspace to read the kernel's page directory. Okay, but apart from that kind of odd thing, actually, was it replicated here? Yes, it kind of was. So apparently there's like some special mapping that allows a process to observe its own page directory. And to be clear, that's not something like any production OS will allow you to do. That's like, I don't believe like to directly read the page table entries. Maybe not. At least I've never heard of that on like Linux, for example. Although maybe there's some weird thing in /proc that I don't know about. Anyway, check in the chat. Hey, Waddle, where did you learn all of this from? Man, I learn a lot of it right here, right now, basically, as I do these assignments and stuff. But in general, I just have been interested in this field for like 10 years, basically. And I've just been trying to slowly learn things over time, and through different jobs and stuff. But I am very much learning a lot of this literally right now on the spot, so. But if you want, I will link you to my resources page, which I made, which is just a couple like links to some books and courses and stuff like this. If you want to learn more, if you want some resources. Okay, so let me use Kern PageDir as a template. Basically, I need to implement a lot of the same stuff that, so specifically what? That's kind of the question. I don't actually know what this should look like really in the end. And initialize the page directory. The VA space of all envs is identical above utop. So utop is here, and then like the upages, the uvpt. I still don't really know what the ulim thing is. The initial VA below utop is empty. Okay, so like fully empty, I guess. feel like there's like there's such little guidance, which I guess is what I could expect. Like as the class goes on, there's less and less guidance. Are there any checker functions? Like what does trap init do? Nope. What about env run? Nope. Like there's no helpful check functions that are provided to us, I believe. Which is hardcore. Load iCode. Okay. Yeah, no, I'm very much on my own right now. I'm totally on my own, I think. So I'll just need to do my best to guess what I think it wants. And I think what I'm kind of inferring based on this comment is that, okay. I mean, this comment is pretty clear. The initial VA below UTOP is fully empty, so I don't need to do anything there. All I need to do is initialize the various entries to map, I think, similar things that appear in the kernel's page directory, which specifically, so ignoring the virtual like self mapping, it's what I look for all the places current page dir is used is called. I guess check current page dir is sort of a reference, but it's basically these four things. It's the U pages, it's the U pages thing. So U pages, M's array, I guess. Kernel stack. So my first kind of gut reaction is, why does the Userspace process need to have all this stuff mapped in there? But then my second answer is like, well, clearly it's because the kernel gets mapped also into Userspace virtual memory just at high addresses to facilitate higher performance context switching. So so it can always be mapped. And I guess that's the reason. I guess that's the reason why all this kernel stuff needs to go there. And so in the absolute worst, ugliest version of this code, I could just copy and paste everything. I could just copy and paste all of this, which I kind of am tempted to do. If I were to try to do this code a little bit better, kern page dir mappings to do, don't copy paste this code. Yeah, if I were trying to do better programming right now, I might try to extract a function or something. Okay, I'm missing an em's size. Missing an em's size thing, which I'll get from here. Yo, I gotta say that shirt is sick. Yo, thanks, Digitalized. Appreciate that. I am a huge fan. Massive fan. Some water. All right, that was my best guess at the ref count, like they said. Set this thing. Okay, but I need to be careful to not directly copy and paste the code because I need to be updating. Okay, what I'm going to do is I'm going to env page dir. Right. Get the pointer, set it, and then basically these 4 things I'll go to env page dir. Boom. All right. And I don't know if that's super correct, but that's following the hint that said, can you use current page as a template? Hint, yes. And so I'm just kind of doing exactly what I did before, mapping in the U pages, mapping in the UEnvs. I said to make sure the permissions were right. So double check those permissions. I mean, I'm pretty sure those are correct. Yeah, I don't know. I think, so I guess I did the function. I don't really know. I'm just gonna do a whip commit. Okay, it's gonna be whip and setup VM. Not totally sure this is correct. Correct. Just copy pasting current page dir setup. Right. Okay. Region alloc allocates and maps physical memory for an environment. Let's do it. Region alloc allocates len bytes of virtual memory for environment env. And map it at virtual address VA in the address space. It does not zero or otherwise initialize the mapped pages in any way. Pages should be writable by user in kernel. Panic if any allocation attempt fails. This is kind of funny. Lab3 UR code here, but only if you need it for a load I code. What do you mean, only if I need it? I have no idea if I need it or not. It's weird. Hint, it is easier to use region alloc if the caller can pass VA and len values that are not page aligned. You should round VA down and round VA plus len up. Watch out for corner cases. Man. Okay. Okay, so we have a given environment. We have a destination virtual address to put the mapping at. We have a length of the mapping. And it's saying, ideally, the caller should be able to pass values that are not page aligned. Maybe I'll do that in like a step 2. And for step 1, I'll just try to make this work and assert that va int pointer t again, I'm just kind of, there's probably a better way to do that. Check that it's page aligned, but that's just kind of what I'm thinking of right now. And 20-second break to stand up and stretch. All right, and I'll just assert that len is also page aligned. I guess I could also do the assertion with like a bit mask, where I and it against a bit mask of the low 12 bits or something like that. But I'm just not gonna do that. Hey, Rational. Whoa, kernel, yeah. Kernel development, kind of, yeah. The final boss of coding. There's always a next final boss. But it's definitely a big boss. Okay. So I'm doing this. I'm trying to take a baby step here. Okay. Allocate len bytes. So I'm going to do a page alloc. Page info, something like this. Definitely not inspired by Terry Davis. Definitely not. Yep. Nope. And I'll pass in my 0. And if that returns null, it's just a panic. All right, I can do that. Yeah, no, it's VS Code. Yep. All right, so I am have my do not increment the ref count of the page. So do I need to increment the ref count? Ref count. Can we write the kernel in C++? Yeah, definitely. Definitely. A lot of people do that. I would love to do that one day, but I'm not quite there yet. I'm not quite ready for that, but I'm a fan of C++, and so I would like to be able to use that. I think so. Just curious, page insert. Page insert assumes you already have the page info, so that's not usable by us right now. I'm just gonna say yes. Bump the ref count. We need to do this, right? Is it better to code kernel in C or C++? Yeah. C is definitely simpler as a language than C++, but you do make trade-offs. Like, it's simpler, but you make trade-offs mostly in terms of type safety and compile time safety and stuff. But then in exchange for in exchange for doing that, you get a lot of just simplicity of the language. It can be easier to understand sometimes. I don't know if it's a better or worse kind of thing. Most of the production operating systems in the world are written in C. I think maybe for historical reasons, but maybe also for legitimate reasons. Like OpenBSD, FreeBSD, Linux. I'm less sure about macOS and Windows. I think macOS, the main kernel is written in C, but then it has this object-oriented thing in C++ for drivers, but I kind of want to say the main kernel is written in C. They also use like the mock microkernel, which is written in C also. Yeah. Okay. Allocate the memory, right? And map it at a virtual address VA in the environment's address space. I feel like page insert might be what I want, right? Let's look up the, so it takes into pagedir. I have that. pagedir. And I have the PP. And I have the VA. And I have, oh wait, no, I'm kind of messing up. So, right, I'm just allocating, oh wait, what page? Interesting. Page alloc only allocates one at a time. But I need to support an arbitrary size here. Interesting, okay. So maybe it's kind of hard to ignore. I don't know, I'm just gonna pretend, I'm going to do this in various stages, like step 1, only single page args must be page aligned. Then a bit of a harder mode, do the non-page aligned support rounding, etc. And then the intermediate step is support multiple pages when. Right. I think that's how I will break this down. Yeah, OS is in Rust. Yeah, it's very cool. Very cool stuff. Yeah. Yeah, that is true. Although with kernel programming, generally you don't really use libraries anyway for it, because the majority of libraries are not meant to run in the kernel. They're meant to run in Userspace applications. So I would be kind of a bit surprised if there are that many libraries you can really use from the kernel, with maybe some exceptions. But for the most part, I think a lot of people just like write everything themselves. Okay, let's focus. Okay, so basically, before I realized that I was doing this kind of wrong, page insert. Oops. Okay. Page insert takes what? The VA and the permissions. And it's saying it should be writable by user and kernel. which means PTE writable, PTE, and PTE user. And it should add the present bit for me, I think. Yep. So this is the simple case. This is the simple case where I only support calling region alloc with like I only support allocating one page at a time. But now I'm kind of seeing that, yeah, we need to be better than this though. But just before I jump to the next step, does this work? So let's say you pass in some virtual address. Let's say you pass in, I mean, it doesn't matter. We're gonna assert some stuff here. Also, just out of curiosity, where is this called? It's not, is it used yet? No, it's not. It's like not used yet, so. Yeah. Man, chat's on fire today. Start with C++ for sure, because I've decided it. Yeah, I mean, C++ is like can be very challenging, but it's also a very powerful language, definitely. I found that learning C before C++ was like kind of useful, though. Yeah, what happened to the NVim setup? I have never used NVim in my life. And yeah, I'm developing on a Mac. Yep. Okay. Page alloc and panic. If any allocation attempt fails, interesting. Right, so we get our thing. We bump the ref count, and we insert it where it needs to go. Okay. So I'm going to stage this, I guess. I'm going to stage this and then work on part 2. So step 2 is going to be support multiple pages, like actually interpret length. Also, wait, yeah, is it? Interesting. I actually haven't thought about alignment too much for the virtual address. I don't know, like, do I support that? Man, alignment. I have not thought of this before. Yo, Clockwork, are you iterating over pages in a storage or using a linked list? Or are all pages the same size? All pages are definitely the same size. Iterating over pages in a storage or using a linked list. It's actually, I mean, it's a linked list, like like there's like these page objects that are all allocated. Let me just pull up the visual. I think this is what you're asking me. This is how I manage physical memory. It's each physical frame has and like an object associated with it, they are all allocated together contiguously, but then they internally have linked list pointers, and the actual data structure is a linked list. But alignment, man. So far I've not thought about this, and like what, where would I even, and okay, all of the tests so far, those check functions that I passed, I think they were just using like hex 4K or something as the virtual address. So they were not testing anything where it was unaligned. So I think I kind of do assume proper alignment, actually. For example, with page lookup, pagedir walk. So what does pagedir walk do? It extracts bits from the address, where is the diagram? Or was it here? Okay, yeah, here it is. It extracts bits, but it never uses the offset, I think. So if you pass in an unaligned value into pagedir walk, it's effectively going to round it down to the nearest page, just by virtue of not interpreting the low bits ever in the, in the function. So I think that technically works. Again, page lookup, just pagedir walk, simple. VA is not used anywhere. Page remove. PDX. What's that do? I think this also Anyway, yeah, so this macro also doesn't care. It just takes this thing, shifts it down, and extracts the bits. So actually, I guess a lot of this stuff does kind of work if the alignment is not, it's not aligned. But I feel like it would be cleaner to not rely on that and to manually so round down, you enter pointer T, VA, something like this. and rounded. Just curious, are there any other uses of round down? No? What about round up? Round up. Yeah, you pass in something and you pass in kind of the way you're rounding it. So, oh man, I have not been keeping up with the chat. How do you know how long something like Userspace will take when I do projects? I think they'll take a day and then end up taking a week to finish the module. Man, I don't know. It's very hard to predict these things because I have no idea how much work it's going to be. I don't really even try to predict. All I try to do is just come here every single week and make some progress. But it took me about a month to get virtual memory going. All right, 20-second break, be right back. Yeah, it took me like a month to do the virtual memory stuff. So that's like my only data point. I think Userspace will be harder than that. So I am probably going to, yeah, if I had to estimate, maybe a month, maybe 2 months. But to be clear, 1 month of only doing it for 2 hours a week, because that's all I do. So yeah. 4 sessions of 2 hours each. VA rounded, and I want to do a similar thing when rounded, and I want to round that up, round up. Yo, what up, Sid? Good to see you, man. Some crabs in the chat. Oh, hey, Corey Bot. Nice to see you too. Yeah, agreed. Building real-world projects is a good way to learn. Yeah. All right, got my rounded. Watch out for corner cases. I don't know. What does it mean by that? What would a corner case be? Corner cases are like if it is exactly aligned already, if it is in the middle of the page, if it's like one away from being page aligned. I feel like those are all covered. What's the problem with unaligned addresses? Well, just like first off, I'm kind of thinking about this because of this hint that the code says it is easier to use this if the caller can pass non-aligned things. So that's kind of why I'm thinking about alignment. And in general, it's an interesting question because all of this virtual memory and page table stuff is a little bit sensitive to alignment. A lot of things kind of only work at page size boundaries and stuff. And it wasn't totally clear to me, because I hadn't thought of that before, if I'd wrote the code in a way that required page alignment and stuff. So yeah. So I'm just gonna hope that this is right. VA rounded, len rounded. So round VA down page size, round len up page size. But wait a sec. Round VA plus len? VA plus len, interesting that it says, I mean certainly, yeah, but I think that's kind of the same thing as just rounding len itself up. I'm just going to do this. And I think I need a loop. I don't know what the loop is yet, but maybe I'll figure it out as I type this. I need a loop through every it's like this is going to be offsets, something like this. I again don't totally know if this is how correct this is, but yeah, plebish. It's I'll link you to the course, like this MIT course. So this is the way I usually go about doing these things. I like have like the full size like in a variable, and then I iterate with like offsets into that. Iterate with offsets into that buffer basically, and I just bump it along at page size, I think, which is right. So that's going to be the offset. And then, so for each one of these, it's going to be something like this. So for each one of those, I'm going to need to allocate a page. Oops. And I mean, basically, is it really just this? But the difference is I need to insert it at the right place. Best VA equals pointer T VA rounded plus I basically. And I'm a little bit surprised that this that didn't give me a warning. So here's my guess at what this looks like next. And I kind of want to write some unit tests for this because this is kind of hairy stuff. There's signals course right now. Very cool. I think this is getting closer to being right. Allocate len bytes of physical memory for environment and map it at some virtual address. Don't touch it or even zero it apparently. So yeah, I take my inputs, I take the virtual address, round it down, I think. I'm pretty sure that's correct. And yeah, I'm just gonna write some test cases. Simple aligned. Corner cases. Maybe let's brainstorm about corner cases. So VA and len. So one could be 0, one could be that was in 4. -1. It could be like 0. Interesting. Yeah, what happens if 1 is 0? That's an interesting corner case if it's yeah. Then nothing should happen. But I kind of like explicitly catching these things and returning early if possible. So if, like, basically these are the main. If it's 0, if we've rounded up to a page size, it's going to stay at 0. And we want to just do nothing there. If it's 1, we want to bump it up to 1K or 4K. Yeah, I think those are legit. For VA, it's kind of similar. It can only be but even hex 0 would be a valid VA technically, so simple aligned. 0, maybe like 5, basically everything I just wrote. Simple aligned, page size, multiple page sizes. Up. Yeah. Just gonna visualize this just in case it helps. So we have the buffer, basically, VA points here at the beginning, and we have some length, and we have, kind of wish I knew how it's, maybe I'll make this a bit smaller and then just duplicate it. So pretend those are totally aligned. So I have some pages, and then len is going to like be, maybe I won't use an arrow, maybe I will use a line tool. And len is going to be like someplace here, and it can be in various positions. It can be like ideally well behaved, it should be page aligned, it can also be non, and so we're always going to do this rounding thing. So len rounded, and also potentially VA can be kind of weird. and pointing at odd offsets. So we're always going to make it look like this. And I want like a bracket. Right. And so ultimately, I want to make it a bit thicker, but whatever. So this is the region we want to operate on. And so we do, and then we just loop through with our I. Oops. So we have like the I equals 0. And it has to be, and we move until it's less than len rounded. So if it's like 4K, starts at 0, bumps to 4K, and that's not less than 4K, so we don't continue the loop. So I think that's right. And for each iteration of the loop, we allocate some physical memory, bump the ref count for whatever reason, compute. So we basically like get some physical memory, compute this alignment point, where it corresponds to, by taking the base. Maybe I'll call this VA rounded base. And then adding our page offset, which is I is page aligned. And then that is going to be the destination virtual memory. We insert it into the page dir with this thing. And I'm like sort of wondering what's the deal with this alloc thing? Like, is it a memory leak to just like allocate it and then forget about it? But I don't think so, because that info is recorded in the page tables. So if we ever do page remove, I believe it like properly frees things. It's able to look up the page. So yeah, I think that's not a problem. Hey Drew. Hey Drew, nice to see you. How are you doing? Okay, I am just gonna say yeah. Let's go for this. And let's see what's our get. So I did a basic, and alloc more complete. And I just out of curiosity, I wonder what it would look like to add some tests here. And I guess I would do that here. I would have check region alloc or something like that. But it's a static function, whatever. Check region alloc. I'm feeling a bit, I'm apparently in a kind of a unit testing mood today. Check region alloc. Okay. And what do I do? It's a function that takes in struct env, so I feel like I need a struct env at the very least, and then env init, right? Or no, wait, env init doesn't take any arguments. Okay. So never mind. How do I zero? I kind of hate doing this, but I always kind of forget how to size of and wait, man, how do you call memset again? What was it? Destination? Oh, 0 length. I see. Okay. So size of and okay. Zero it out, and I do need to make a page directory for it. Where did I do that again? End of setup VM. Oh, right. That was the one. So unfortunately, it's kind of messing with the actual, I mean, it's actually using the page allocator to do that, but whatever. Just gonna do my panic, or oops, yeah, I'll just do my panic tests, region, alloc, tests, pass, and let's run it. Implicit declaration of, oh, dang. Did I not, have I not compiled in such a long time that I didn't notice that boot map region? Is this a static function? It is. That sucks. Maybe that's a small sign of encouragement to not copy and paste all this code like this using such a low level implementation detail. It's a little bit more than I care to do right now, so I'm just going to make it not static and try again. Does that not work? But do I need I probably need to expose it. Oops. Here now. Maybe. What about now? Oh, previous declaration. Static declaration follows non-static declaration. What? Oh, I see. Okay, so now I remove that. Okay, now we're compiling and running again. Although there's a bit of that technical debt around the boot map region thing. 314. So now I could technically check region alloc. And I could try to, I don't know, do some unit testing, like, yeah. Or I was trying to, yeah, and no, it's like region alloc, which also annoyingly, okay, it's a static function, but I'm within env.c still, so I can call it. So I don't know, what do I want to call it with? For example, I don't know. Like, does this even work? Oh. Okay, so I think I need to move, oh, I need to move this a little bit lower. Oops. To be able to access it. Yeah, I think I left a stray line here. Okay. Yeah, so now I can makes pointer from integer. Dang, all right. It would be nice to just, yeah, I'm just gonna do that. Okay, so it says it passed. That doesn't really say very much because in order, like, it doesn't check any kind of return value or anything, but it didn't. I see. It's like it just has side effects. So yeah. Okay, in order to really test this, I think I need to involve the page allocator. Which is annoying. Like, in theory, I could do a unit test where I guarantee that the page allocator is in some kind of state where I know that, like, this page is the first one that's going to be like used on the next allocation, and then so I can set that up. Then I can call region alloc, and then I can do some assertions. Like I can assert. I can then like go into the page tables and examine their state, and I can verify that that page was used to satisfy the region alloc thing. So that's technically possible. Break time. Also, we're past 6, so I need to get going soon, but I'll keep working on this a little bit more. But 20-second break. Drink water. Yep. Pianist. Yeah, I'm trying. I'm not that good at piano, but I like music a lot. I play musical instruments, so yup. Okay, there were some other tests that did similar things, but just for fun, I'm just gonna try. So I'm going to allocate a page. Are you also a pianist, Rational? Okay. So allocate a page. And then free it? Man, I don't know what I'm doing. Check page alloc. Yeah, there's like these other tests that do very similar things. But that's, yeah, check. What about this? No, that doesn't do anything with page. Oops. Go there. I'm looking for existing code. Yeah, it was like whenever like a PP0 thing was mentioned, that page free. Yeah, for example, this was a test that did a similar thing. It allocated a bunch of pages, but then freed one for some reason that I didn't understand though. Oh, and then it used it in all these different things. Let me just give it a try. I think my idea was kind of sound. So page free. So I know, so basically I got a page and then immediately freed it, which means it's going to be on the top of like the linked list or whatever. And page lookup. What is it? env.pagedir. This is going to be annoying. Void 1000 and p, sure. So this is getting a bit confusing. So pair this goes together. I'm just going to temporarily put this in braces to have some separation. Okay. Why is... Can you not do this in C? No way. Oh, okay. Okay, maybe that's not legal C, I don't know. Right. Okay. So this needs to be passed as a pointer, and then what does that build? No. Okay. This build? Yes, okay. And page lookup does what? It returns, yeah, it tries to basically query the page tables. Page info. And I can try to do something. It's like I can try to assert that it really got one. And I can even try to assert. Oh, ew, what happened? Okay. That pp is equal to p. I am pretty sure that's legit. Let me try. I'm kind of curious if it works. And all region alg tests passed. Okay, word. Which is kind of cool. I think that should have worked. Huh. Yeah. What's the name of the kernel? I don't really have a name for it right now. I used to call it Garden OS, but I kind of I decided that I don't have a name for it at the moment. I haven't named it right now. But if you want to call it Garden OS, you can call it Garden OS. Okay. So now I can inject a bug into region alloc, such as always failing. Not exposing. Okay, a privately named kernel. Nice. Yeah, for me, like, I think giving it a name puts a little bit of pressure on it to be something, and I kind of don't want to have that. So I'm not really giving it a name for the moment. I'm trying to keep it very, very low pressure. But okay, back to on topic. Assertion failed PP. So that's cool. That means that the test is catching the bug I just injected. So the bug is such that this function never does anything, and that is detected by the test being unable to find a page info when it should have been. So that's kind of cool. And I am again just curious. I feel like this should work with this. Oops. This open braces thing. Yeah, totally. That should totally work. Garden X. It's cool now. Nice. And the X thing, yeah. Right. Yeah. What else? I don't know. Did I even need this PTEP thing at the end? I don't know if I did. What else do I want to assert happen? I want to assert that it allocated this thing and pointed at it correctly. And I think that's what this tests. So page lookup tries to query using that virtual address and see what it can find. And if it can find something, it returns back the page info that the page table entry pointed at. So I think that's pretty legit. So I'll get rid of this. And I will, oops, call this null. And I have not implemented the free function, so I have no way to free. I don't know what the opposite of region alloc is. I have no way to free things, which is kind of unfortunate. But yeah, so now I can potentially try some of these other tests with like the different alignments and the different sizes of things and whatever. So simple case. So multiple pages still aligned. So now let's do another simple case where I ask for 3 pages. And maybe I can even test the alignment thing by doing this, which should still work. So now I need 3 1, 2, 3, and I need to release them in the opposite order. So we got 3 pages. I put them back exactly as they were. And then now I'm going to do a region alloc again at this address. And I need to do a few things. So it's going to be a very similar test. But yeah, I mean, it's basically just this thing 3 times. But just change all these things. Right? But no, but this is wrong. It's because now it's like it's 2 hex 3. I am very curious if this works. Test passed. Nice. Okay. That means this actually works. So I actually do support I think the rounding seemed to work. And I can inject a bug. So yeah, whenever you write a test, you always want to see it fail at least once. Never trust a test you've never seen fail. That's some advice I have read or heard or something, whatever. And so I've never seen this fail yet, and so now I need to inject a bug to see it fail. And one interesting bug would be like what would happen if I didn't do the round up, for example. Although I don't know, it might still work actually. But what would happen if I didn't do the loop? Like if my loop was wrong? Like if I just didn't loop, this should fail, right? Oh, okay, that failed in the even earlier test actually because that relied on this too. So I need a different bug. I'm just gonna do like if I is greater than 1, break. That should have the first test working, but the second test should fail because it'll work for the first iteration. Hey, all right. Hey, Ujwal, nice to see you. What color scheme is this? I don't even know. Everyone was complaining last time about my color scheme. It's called Quiet Light. Yeah, Quiet Light. Okay. Assertion failed PP2 391. Very cool. So let's check that out. So that means, yeah, that's totally what I was kind of hoping for. So the first one worked just fine, but now the second one starts to fail because this thing doesn't work on additional loops, and I can make it this to even see the third one fail, hopefully. Oh, interesting. Wait, the same thing failed. Actually, wait a second. I realized I kind of made a mistake. So it's 0 indexed. So in this case, 391 fails. But why does this succeed? Or, so it's like 0, 1, and 2 are going to be the indexes. And maybe I'll just do this a bit more directly. If 1 equals 1, break. This means it should only work for the first one. And it passes all to, what the? Oh wait, whoops, no. Oh, I see. Yeah, no, I'm being, it's not an index into the frame, it's the actual buffer. So that's why. So now, this is going to fail on the second one. PP2 failed. Now, this is going to fail on the third one. PP3 failed. Perfect, okay. So that's just injecting some bugs to make sure it works properly. I could also do some checks with the permissions, but I kind of don't think that's necessary. I could do some checks on the ref count, but I don't think that's necessary. And I could do one of these more exotic tests. So now I can do some really kind of messed up. I'm gonna not do 3 pages, I'm gonna do 2. I can do some really messed up stuff like 1030 or something like that. And I mean, I already kind of tested this, but 2, 1, 1, I don't know. It's like these random things. But if I'm only allocating 2 pages, I need it to be like 1. Hey Linux. Okay, yeah, I do need to get going, but this is just too fun. Okay. So now now my virtual address is not aligned, but the end output should be the same. I should be able to query 1000 and see page 1 being used. I should be able to query 2000, see page 2 being used. And that works. And I don't quite know what bug I could inject. I could just like not round it. I could just straight up not round it, but I don't think that, yeah, but that was kind of the thing I wasn't sure about, because it's kind of funny that it's kind of not necessary, because actually page insert and all these whatever kind of handle that. Although this is interesting that like passing an offset to an unrounded base is not, it's not really good. I don't know. I think I will just leave it at that to say that I feel like the code is pretty decent, actually. It passed these little tests at the very least, which is kind of cool. Never saw a failure, but I cannot really test this because the code crashes the kernel if that happens. I can't, from a test, I can't like create that precondition of there being no memory, then call the function and then verify that it worked, because when I call the function, it'll crash the kernel. And I'm running these tests just in the kernel. So I am going to call it there. One last run just to see it working. Region alloc tests passed. Nice. Yeah, I think I'm gonna call it there. Bring the stream to an end. Thanks a lot for joining. And if you're new here, welcome. I'll post my Discord link as always for anyone that's interested in joining the Discord and hanging out a bit more. I do this every week. You know, like, comment, subscribe. Hey, Udhaya, I'm literally about to leave. But thanks for joining. Yeah, I'm here every week. Feel free to come back again if you are into operating systems and stuff. And with that, I'll end the stream and see you next week. All right, bye.